Hi everyone. Uh, to the best of your knowledge, is anyone else aware of any if anyone else would be joining? Otherwise, we can begin the class. Okay, so then we can begin. So yeah, till the last class, what we had done was understand till the mathematical modeling aspect here, and we had discussed that if that everyone else would be going through the paper, and we will be discussing about the paper. And if you guys have any doubts, we'll be also discussing about that. So yeah, so so who of you was able to go through the paper till now?
Yes, sir.
Okay, so what do you think about the paper? Like, what about the equations?
Little bit tough actually to just like couldn't completely connect them here.
Yeah, it's a little difficult as well. I agree.
Can you please come again? Hello?
It's not very intuitive, at least for me. I mean, like, I definitely went through the paper till you had asked us to, but it's not very intuitive. But I have just a very small idea.
Yes, go ahead.
Uh, Give me just a minute. It's basically the model revolves around three terms. I actually forgot what those terms were, but these three equations actually just describe the changes in these three terms only.
Yes.
The abstract mentions them, but I currently have joined from phone, so I don't remember exactly what those terms are. Really sorry for that.
Okay. We can take out the open the abstract. It's not an issue.
Yes, yes, yes. We have yes, gas
I,
infall from galactic halos
yes.
and yes, these three basically just terms like the
Yes.
terms mentioned in the second and third line.
Yeah. Yeah. These are the like the primary three processes, or let's say three scenarios that the paper is focused on. Hello.
Yes,
Yeah.
I've actually that is what I said. I mean, that is, I guess, just a gist of my understanding.
Yeah. I mean, you will have to actually invest some amount of time. Yeah, because this paper is actually a technical one, and it definitely takes some time. But yeah, you need not concern yourself with this point right now. Oscillatory star formation process, as the present model, like up till the mathematical equation, we are really focused on these two terms: the galactic halos and outflow of gas by the supernova explosion. So yeah, so like up till what did you find the like were you able to understand the paper?
Am I supposed to answer?
Yeah.
Like me? Acha, okay. So,
Yeah.
I got a general idea of the abstract, and I was through reading up till the first paragraph of the introduction. Can you just scroll down? Yeah, that
Yeah.
I like in bits and pieces. I understood. Then I just copied and tried AI assistances to get an idea, but nah, as a I didn't get it quite well.
Okay. Yeah, see, well, see, when you're reading a research paper, no, it's not possible that you understand everything. there is this problem, and some researchers would agree, some researchers would not. However, majority of the researchers know that when you're trying to study and analyze a paper, you can always analyze some aspect of it, like the part that is like that you want to concern yourself with. Like in this paper, it's mathematical modeling that we need to study. And honestly saying about the chemical analysis part, whatever the chemical reactions that have been discussed in this paper in the second aspect, I have seriously no idea what they are doing there. So sometimes you have to take out the areas that are of specific concern to you and just focus on them. So yeah, like also like were you able to understand these chemical reactions? And also I would encourage everyone else to join also, because today's session is mostly about more interaction and discussion about the paper than it will be about like normal classes where we'll be just teaching and discussing about it. So everyone please interact.
Actually, the part where they, they transform it, they take that xc plus, sorry, xc plus xw plus xh equals to 1, and then instead of three equations, they convert it into two using the total, the total equals to 1. Actually, that part was a bit challenging for me to understand.
Okay.
Yeah, like the transformation which they did.
Okay. Can you please tell me about your educational qualification till now?
I'm in 12th grade.
Okay, so have you done different like application of differential equation chapter?
Actually, it's going on right now. I have not studied it completely.
Yes,
Uh,
actually, until you won't study that topic, that's why you may be facing a lot of doubts the related to the differential equations here. And see, this is what actually what we are doing. This is substitution. Tau is equals to CT. So you are applying the method of substitution. At the same time, you are normalizing it through these terms. I can share with you the mathematics aspect. It's a normal thing. I can solve the equation and I can share it with you. However, you won't be able to get like a complete picture of it until you have read about the differential equations in detail.
okay.
Yeah, I'm sorry, but like we
Yeah, I
cannot do
understood.
anything.
Yeah. Like after some time, I think I'll come back to it, and then maybe it will be clear.
Yeah, sure, sure. You can always reach out to us in any time and we can let you know. And yeah, Harshvardhan, what about you?
It was me only.
Okay. Okay, it's very hard sometimes to tell the person from voice. Wait, I'll open it like this. And Nikhil, Swati, Yash, and others. Like how many of you were able to go through the paper? Because if you haven't gone through the paper, then there will not be a point of class today. Hello, am I audible to anyone?
Yeah, you are audible.
Okay. Please show through like tell through a show of hands if you're able to go through the paper. Thank you, Devang. Thank you, Aryan. Okay, thanks, Ashwardhan. Okay, Devang, Aryan. So, what do you guys say? How are you able to go through the paper? Like, how did you find the paper to be?
Um, like to be honest, I don't think I understand that much. Because the thing is, it's like I'm not able to get. Sometimes, like if you know what the problem statement is in clarity, then you can walk towards it. I think that is something I've completely missed out on while reading.
Okay, the problem statement.
Yeah, I mean, I know we're definitely trying to like uh, build a mathematical model, but I don't understand what is the intuitive idea around which we're building the math. And it's just there are so many terms like star formation history and whatnot. It's just like it becomes really confusing.
Okay, I'm sure we can discuss about that. And Devang, what about you?
I can't exactly say that I understood everything. Like the physical phenomenon that is happening, that is somewhat I can simulate, but equations are a little bit tougher to get. I guess. Like even though I'm doing research on theoretical physics only, but still it is not like completely understandable.
Okay, so I think I know what you guys are going through. It's
Yeah,
that.
actually, it is actually better.
Yes, yeah, yes. Can you
Sorry.
repeat?
Yeah. It is actually very good if we have some hand-on session for this versus simulation actually, especially in the simulation part.
Simulation aspect, like a class majorly focused on where we are modeling the equations.
But yeah.
Hmm. Okay, so let's see. So see, the way I see it, there are actually two kinds of problems that you are seeing. One is that you guys are lacking in the theoretical perspective.
No, sir. Actually, it's is like I don't know about other people's perspective, but like from me, I'm understanding like what physically in the system is happening. Like I can simulate like what is happening, but when it comes to like equations, then it is a little bit tougher.
Okay, yeah, actually, I was about to get to this. By theoretical, I'm meaning, Dimang, that see, there's a lot of like past works focus around this work. Let's say there have been, I think, 20 to 25 research studies that have been solely been focused on this. And what you are seeing right now is an accumulation of all of that put through the modern lenses and the literature and explaining all of it like in a simplistic manner. So to get how these equations have been developed, what we may do is that we could go back and review the papers that was proposed back in 1989, 1977, read a bit about that and what are the like assumptions that they are taking, what is the basis of that assumption. Through that, if we do that and then we come back and then we discuss it, that is one method that we can utilize to understand this paper. So that is what we are seeing. And about the simulation aspect, it's I can show you the simulations right now or through any other approach. It will not take more than 15 to 20 minutes how to analyze simulations. So you need not concern yourself with that about this at very point. What we need right now is that you guys can understand the what these terminologies are representing, and yeah, Nikhil, about the what these are representing, we can get to it after some time. But the way I see it, and also everyone is seeing, we could review some multiple papers and then come back to this paper, understand it, and after that we can go forward with the presentation. Is anyone else facing the voice issue? I think then Yash, it may be at your end. Yash, please check your internet. Otherwise, we can let you know about what we're discussing after the class. So yeah, I think there are only two approaches. Either we can review multiple papers and then come back to us. This would increase the number of classes. However, it would give us more clarity. But in this aspect, you guys will have to do a lot of literature, like reading about the papers by yourself. I can send you some papers, but you will have to go through it. Reason being, because since I said that there are a lot of papers on this, so it's not possible to discuss about each and every paper in the class itself. So either we can do this or we can go directly towards the presentation part. So I would ask your guys' opinion that what approach do you think we should take?
Hello, sir.
Yes, Isni?
I think I would more interested to look for a few more papers to see. It's not that we are not going to go through one by one, but at least we can see briefly the difference in terms of the different models. At least that to grab the idea about the different models that various of researchers propose about the star formation. I think it's not that the purpose is to write to read in details for each of the papers, but at least to grab some ideas about what are the various methods or models that people propose, or different approach for the star formation.
Okay.
That's my suggestion. Yeah.
So, but yeah, Asni, we will need to hold classes if you guys face any doubts. So maybe we can go through about that. I can share some papers with you. And I know about some papers and I can tell you about which paper you should take in sequence to get the best knowledge possible. And based on that, we can have classes and discuss the doubts, and after that we could go towards the presentation. The first part, that the major that is the most important, is that you guys are able to understand what we are doing.
Okay, sir.
Okay, so in that case, let me open some more papers. Yes, also others who are in the meeting, Nikhil, Devang, Neeraj, Yash, you guys please also say what are your opinions.
Sir, I agree. I think it would be nice to go through a few more papers.
Okay.
Yes, sir. We should go through a few more papers.
Okay, so right now I'll be opening all the papers that I have with myself on star formation. And I'll tell you in like what papers you guys can go through, and based on that we can finalize it. Okay, is my screen visible, everyone?
Yes, sir.
Is it visible or not?
I don't think it is. It's the same.
Okay, it's the same. Okay. Okay, so guys, please take out a pen and paper, and right now we will be going through some papers, and I'll be telling you about what paper was proposed first, what paper was proposed second, and how the research study like developed through the years. Because there were actually two classes of studies that were proposed, which later got like they were merged together, and the present model, this is the DSTF paper that we are saying, it's that one paper that we saw. So please take out a pen and pencil. I'll be telling you what paper was proposed first, so then you know what sequence to go for. Otherwise you will be stuck in towards going like going in as much as different types of references and everything. That's just going to waste your time. So please let me know once you guys have the pen and paper in your hand.
Got it, sir. I think you can go ahead.
Okay, I think this needs to be here. So this was, yeah, this is the most recent paper that's been proposed. My paper is actually, I worked on a similar paper. It's under review right now. And this is here. So what we are looking for is this paper. So this paper is, this is the, let's say, the most technical paper that you will ever read on star formation. So please note down the name of the paper, that is Oscillations in Star Formations and Contents of a Molecular Cloud Complex. If you read this paper, I will say that this is an incredibly complex paper. Okay, it starts from the what type of observation evidence, and like starting from the need for star formation, and it through introduction it's saying how it's a nonlinear cycle, and the feedback mechanisms, the things that we discussed about that, like feedback mechanisms that are there through kinetic energy output. We read along those terminologies, so it discusses about the feedback mechanism in detail. And after that, like there are a lot of things, how the loss of thermal energy may lead to gravitational contraction without a raise of temperature. So right now it's just discussing about how the H2 clouds collapse. So it is telling about everything in detail. But the reason is that the one reason that we did not go through this paper was that this paper is quite complex. And like if you want to study this paper, you will need to give at least 2 to 3 days towards this paper itself. And I'm sure you will be able to understand it. But to do that, you have to invest some time. So if to any of you who are facing any of the doubts and like anything, you can always refer to this paper here. It will tell everything and anything in the tiniest detail that you require, but it will require significant amount of time. And you may see that, okay, remember that Schmidt function that we were discussing about that day, that how the value of N1 changes, that N1 1.7, 2.1. And so it is discussing about explaining that paper in detail. And here it's discussing about the feedback mechanism in detail, and how the you must be having some doubts related to that term of MS square. Tell through a show of hands that which of you were not able to understand how that MS square term was like we were discussing about, and you were not able to get it.
Actually, it's not that I wasn't able to understand it fully, but yeah, it wasn't clear that why it should be the square, why
Yeah.
the second order would be there.
Yeah, like that's what I wanted to, like what is the reason for MS square? So yeah, this paragraph is going to explain it. If you want, I can explain it right now in the meeting, or you guys can also go through it by yourself. And this is a 4-compartment model paper, but you need to only consider yourself about the 3 compartments. A, M, N, S, and R compartment is just a waste compartment here. And this is the numerical analysis that they have done. And this is the star formation process, the graphical analysis. So to those who can like who don't want to read multiple papers and just want to focus on one paper, I would encourage them to go through this paper, and it is going like piece by piece. You will require some time to at least go through it, but I'm sure you'll be easily able to clear your doubts in time. Okay, so I'll be sharing this paper. After that, so like this is the, let's say, the one study that's is separate. So let's start going through the individual other studies and large scale associations. So yeah, so I remember one of the participants were questioning how the supernova shockwaves are responsible for like triggering star formation. So this is the paper that you can refer to, and it is going to explain in detail how the supernova shockwaves are going to trigger star formation. Because actually I'm representing multiple papers right now, because each of you may have different doubts related to some aspects of the study that we are doing. So these papers, each of them are focused on one tiny aspect of the study. So if you have any doubt related to the supernova shockwave, please refer to this research study, and we can discuss about what you have found and what you want to further ask related to the paper and the phenomenon that's doing related to the shockwave through this paper. Okay. So please note down the name: large scale star formation, density waves, super associations, and propagation. Okay, so if you have done so let's go to the next paper. So this paper we did. Okay, so this is actually a quite simple study, but it also explains how, like, why we are choosing different type of terms and different types of interactions here. What's the reason for them? So also please go through this paper. This paper has already been shared with you on Monday. No, I think it was shared with you back Saturday, right? Yeah. Okay, so what was this paper focused on? Let's see. Okay, I think, okay, you can leave out this paper. It's not required. Okay, so this paper is again one of the most important papers that was referred to while developing this research study. So there are a series of 2 to 3 papers how this regulated. So the idea interstellar medium regulated by supernova remnants and burst of star formation. This idea was later incorporated into the present study that we were studying about. So yeah, it is components of the ISM. Here it is with the speciality of this paper is that the interstellar medium that is there in the star forming structure, it's been divided into 8 components. This is a warm gas, ambient medium, hot gas, small clouds, molecular clouds, and giant molecular. Okay, it's 6. So then it is discussing about how the final rate of supernova remnants And yeah, these are the different types of interactions that are here. These are the interchange processes that are the proportionality constants. So you can, as you can see, there are 14 of them. And time variation of each component. So it is explaining here the different type of chemical reactions. And after that, after explaining it, it is giving a see what it is doing, a 4 component. So yeah, here it's just analyzing the equation now. And EGB type with an increase of supernova. So it's just different types of interactions and the processes that are going on here. So yeah, this paper is focused on this. This paper is important, but the other one here. Okay, have you noted down the name of this paper? Okay, sure then. Okay, so self-regulating supernova heating in interstellar medium simulations. It's not something that we will be studying about. It's not our research study is not directly focused on this in like self-regulating supernova heating. But to those who are curious about how supernova shock waves are like regulating the interstellar medium chemical reactions, how it's regulating the star formation, how it's affecting the star formation. I would seriously advise everyone to do go through this paper, because this paper is, I would say, one of the most fantastic papers I've ever studied about. So please refer to this. Okay. And so I hope you have noted down the name of this paper. And so this paper is Continuum Model in Distributed Galaxy. Okay. Actually, I just opened all the papers that I had. Okay, let's just go to the equations. Okay, I think you can leave out this paper, it's not required. And after that, we have this paper and this G body field. Okay, this is also an important paper. It's just like that, the oscillatory model one that we, the first paper that we saw. It's explaining everything in detail here, and also explaining, like also going with the observational evidence that how it is being done theoretically, and how it complements the observational evidences also. So star formation regions, morphological similarities. So you can leave this part like anywhere and anywhere where they are saying, okay, this I think you may face some doubts when they are saying, when the author is saying that in this region of the spiral galaxy, this star showed this property. So it may sometimes cause confusion. So to avoid that, you can directly go forward with towards the less like the theoretical reaction that they are saying, and not concern yourself that much with the like here saying in galactic OB association, a substructure can be recognized in a number of cases. And despite a size number of large diversity, size, and luminosities, H2 regions possess surprisingly similar density profiles. So these type of things, they are not that much required. So yeah, now you go towards the process system, and after that, theoretical considerations. And yeah, then you have your paper here, which is showing how the what are the chemical rates and chemical reactions that are being studied. And then do not, if any of you are facing with the problem with the mathematical aspect here, you can reach out to me and I can explain it, or I can send you a solved equation where there are solved solution where there it's explained how this calculation is being done. Okay, I'm actually searching for one paper that Mhm. Not this one, not uh, okay, yeah, this paper also. Formation of dissipative structure and galaxies. So do go through. Okay, the name of the previous one. Sure, Harshvardhan. Yeah. Star formation regions as galactic dissipative structure. Okay. Okay, sure. And yeah, this is the paper, formation of dissipative structure in galaxies. So everyone, please go through this paper. And because yeah, this paper here, the terms that are there, the BXC XH squared and XC XH squared. So all of the terms that you have seen in that previous paper, this was actually the paper from where the motivation, like the major motivation was taken. So go through this paper and I hope all of your doubts would be clear. I'm sorry we cannot discuss everything, every paper in detail here because actually the number of classes that are allowed for every mentor is limited. So I'm sorry. So that's why we cannot discuss about every paper in detail. However, we can clear your doubts and any if you have any confusion related to the paper. Okay. So this is the name of the paper, Formation of Distributed Structures in Galaxies. Have you noted down the name? Okay. So okay, so I think these were the papers. And yeah, this is also one other paper that you can go with forth with if you guys are able to find the time. Limit cycle scenario, star formation history in spiral galaxies. It's not an important one as the others, but yeah, it has been referred sometimes in the studies. So you can refer to this paper also. And a model for the interaction. And this is an important. Okay, so I think we are done. I would request anyone who has noted down all the names of the papers, can you please send me the list either through the chat box or either through a WhatsApp text so I know what all papers that I have to send.
So it will be better if they send it in the group. Like I missed someone. Like,
Okay. So please send that name in the group, list in the group. And please, if possible, do so right now so uh, we can send all the papers. And if anyone has any doubts or anything related to the work that we have to do, so we can discuss it right away. Is anyone sending it? Okay, give me a second. I'm trying to send all the papers. In the meantime, if anyone wants to ask any questions or anything, please go ahead. Okay, I sent all of the research papers. And okay, so and everyone and the person who has listed down the names of every paper and what has been discussed in that, please send it on the group so everyone can refer to it. And like any because I understand because a lot of you and some of you would have different doubts as required as discussed earlier, because some of you have some problems with the simulation. Some please give me a second. Yeah, sorry for the delay. Yeah, so some of you and some have the theoretical aspect here, but they don't want to understand what is being discussed in earlier, and some are at an earlier steps. So depending on that, go through the papers, and I think we should then have the next class on Monday, and you guys can have a break for Friday, Saturday, Sunday, because you will be needing some time, at least 3 days to go through with the papers. So go through the papers and we can get back to we can get back to our discussion on Monday and discuss about some of the papers. And Monday's class would be, I think, for at least 1.5 hours, so we can get sufficient time, because members, because some of you takes 5 to 10 minutes to join. So to solve it, we can yeah, so we should have some ample amount of time to go through the studies. There's no order, Nikhil. Okay, I think I did not exclude that. So yeah, we can. There's no order. If you can start with the Tanaka paper in the that was the most earlier one. From the Tanaka and Hirashita papers, and from the Tanaka and Hirashita, you can go down towards supernova papers, 1 or 2 supernova papers, and after that, you can come to the present papers. Supernova papers, it doesn't matter which paper you do, because all of those papers, they are explaining about what has been discussed and what has not been discussed. So like start from the Tanaka papers and Hirashita. And there's also the author Ikiuchi. So I'm writing down names of the authors in the chat. Okay. So these are the 3 authors. Please note down this name, or you can copy it as per your convenience. And go through these papers first, then go through the supernova ones. After that, then come down towards the DSTF ones. So I think we should require 1 to 2 classes at least before we can go towards the presentation and finalize it. Okay, so do you guys have any doubts or any questions? Everyone else? Okay, so in this case, I think if you don't have any doubt further, so we can wrap up today's class. Okay, so go through the papers in the orders that you require, and let me know on the group about which paper that you would be like, if like like 5 of you are going through one paper, like have gone to 2 to 3 papers. So I would review those particular papers first and then discuss about that in the meeting, because I'm also not sure that if I'll be able to, I remember everything about that. I will need time to review the papers again. So discuss amongst yourself or on the group about what papers that each of you would be going through. And you can send a list of the papers that I've sent, and the papers which have the maximum number of votes, they will be like 2 to 3 of them would be discussed in the Monday's meeting. Okay, so please do this positively by tomorrow afternoon. Okay. Okay, so until then, I think we can wrap up today's class. So thank you all for joining today. Thank you. Thank you. साइकिल लेके साइकिलिंग करने लगा। कहाँ जाना है? देख तो आपका साइकिलिंग करना। ओके, आया एक सेकेंड।